Hi, you're welcome to this YouTube channel. In this video, we're going to be proving this. This is our first question in quantum mechanics. We're given that if u is equal to this integral and is also equal to this integral, we have to take v of k to be equal to this, and the a of k is remaining essentially constant for this range. Then we have to prove that u is equal to 2a k naught ak equals 2 pi into this multiplied by this fraction. So let's jump right into this. Please subscribe to this YouTube channel, hit the notification bell so that you could also get notified each time we upload a video. So to start with, we have u. We've been given u to be equal to integral from k naught minus changing k to k naught plus changing k, and this is ak. A into k equals 2 pi into kx minus v of k t dk. Let's call this our equation 1. So remember, you are given the value. You've been given value of vk. You've been given vk to be equal to vk naught plus k minus k naught into dv over dk naught. So we're going to substitute this value here, and if we do that, we are going to have u will become integral from k naught minus changing k to k naught plus changing k, and we have ak cos 2 pi into kx minus, now instead of having this, we are going to have this, which is v of k naught plus k minus k naught dv over dk naught, right? And then we have dk. So that is what we have. Let's call this equation 2. Let's call this equation 2. So from here, we are going to have u to be equal to now let's open this bracket. Let's rewrite this. Let's rewrite this way. Let's have integral from k naught minus changing k to k naught plus changing k. So this is a k cos 2k, and then we have this. So let's collect like terms here. Let's open the bracket and collect like terms. If you open this bracket, you have kx here, and you have k multiplying this, and there's a t here. There's a t here. Take note of this t multiplying this. So what we are going to have here is going to be x minus dv over dk naught of t multiplying k, because you open kx here, then this k will multiply this t, and then k will multiply this t and the whole of this. So you are going to have it here, bringing this t here, and then the k outside, which is common here and here. Then the next thing is minus. You have to be minus v of k naught, and then you have k naught here. You have k naught here, so this will be minus k naught into dv over dk naught, and all of this t. This t multiplies all of it, and then this is decay, because this t also multiplies this and this entirely. There's a bracket that multiplies this and this entirely. Then we have this. All right. So, but then to solve this integral, I would like us to look at something. If you have an integral, of cos ax plus b, cos ax plus d plus b, this integral is equal to sine of ax plus b divided by a. Sine of ax plus b divided by a. So let's compare this integral with this, where you have a to be equal to this and you have b to be equal to this. So that means we are going to have u to be equal to ak, that is a of k, into, now we have sine 2 pi into this, all of this, x, another bracket, x minus dv over dk not t, and this is k, minus v dk naught minus k naught into dv over dk not t, and this is all divided by 2 pi into x minus dv over the k naught of t. And then we have this, we are taking our limit from k naught minus the k up to k naught plus the k. So we're taking our limit from here to there. So from here now, if we take this limit now, u will be equal to, substituting this value here where you see k and substituting this value where you see k. So this will become, for want of space, let's clean this. So you have this u to be equal to ak sine 2 pi into x minus dv over dk not t, right? And then you have a k here, which is substituting the upper limit k naught plus dk minus v of k naught minus k naught dv over the k naught. This is multiplying t, bracket close, then minus another bracket, x minus dv over the k naught t into k naught minus the k minus v k naught minus k naught dv over the k naught of t. So, and this is all divided by 2 pi into x minus dv over the k naught of t. Let's call this equation 3. So from trigonometry identity, from trig identity, when you have sine x minus sine y, this is the same thing as 2 cos x plus y over 2 sine x minus y over 2. So comparing this left hand side with what we have here, we see that we have sine 2 pi here, and then if you open this bracket, this will be sine 2 pi x and then minus sine 2 pi y. So we are going to take this here to be our x, I will take here to be our y, which means our x is going to be equal to 2 pi into x minus dv over the k naught of t into k naught plus change in k minus v of k naught minus k naught into dv the k naught of t. And then we have our y. Our y will be equal to 2 pi into x minus dv over the k naught of t into k naught minus the k minus v of k naught, it's a bracket here, minus v of k naught minus k naught into dv over the k naught t. So these are our two values. So now what we are going to do is we are going to be adding these values as we've seen in this formula. We are going to be adding this value and we are going to be subtracting these values. So when we add x plus y divided by 2, what we are going to have is, so from here, if we open this bracket, if we multiply this k naught by opening this bracket, we are going to have this to eliminate this. This will be minus dv over the k naught t k naught, then plus k naught into this. So that minus plus is going to cancel out this. So which means we are going to have x plus y over 2 finally to be equal to 2 pi into x k naught minus v k naught of t. So that is the value of this. So we are going to be solving the same thing for x minus y, and then when we have it, we are going to come back to substitute it into this formula. So now we are going to be subtracting x from y from x over 2. So in the same way we did, we are going to factorize 2 pi out, then open this bracket and then subtract it, open this one too, and then subtract it from this. So if we do that, we are going to have x minus dv over dk naught of t multiplying k naught, then we have plus x minus dv over the k naught of t multiplying dk, we have minus v of k naught multiplying t plus k naught dv over the k naught t, and then this is now minus this y, we will have it to be minus of x minus the v over the k naught t k naught. Then this is plus, no, minus, with this minus become plus. Then we have plus x minus the v over the k naught t of change in k. Then minus with this will become plus v of k naught t, and then also minus with this will become plus, but then another minus on it will become minus k naught into the v the k naught of t. So if we make a comparison, this will subtract this will subtract this will subtract this. So what you have remaining is that y minus y over 2, x minus y over 2 will be equal to, remember this is also dividing 2, so it means you have this 2 into, this is the only thing remaining, 2 of x minus the v over the k naught t, changing t, of changing k. So this is the same thing as 2 pi into x minus dv over the k naught of t. This is the k, changing k. So this is our value for x minus y. So but remember, we are going to substitute this into this this formula. So substituting that now, remember our x plus y over 2 was equal to, going to be 2 into cos 2 pi into k naught of x minus v k naught of t. Then we have sine 2 pi into x minus dv over the k naught, changing k. Remember, this is what we had, and this is going to be divided, or divided by 2 bar into x minus dv over the k naught of t, because remember from here, this is what we had. So we factored out this and this, so we are putting it back into here. So instead of having all of this, we are substituting this. So it's the same thing here as saying that this is still multiplied by 1 divided by 2 pi into x minus dv over the k naught of t. So it's the same thing as multiplying this by this. So we are substituting this into equation 3. So that is what we have. So we have this. So we are going to be solving this further. So which means we are going to be having our u. Our u now will be 2a, this 2 here, 2a, compare our u, 2a into sine 2 pi, this sine 2 pi of changing k into x minus dv over the k naught of t, multiplying, no, this is dividing 2 pi into x minus dv over the k naught of t, and this is multiplying cos 2 pi into k naught x minus v of k naught t. So this is proved. This is our proof, and this is our answer that we've been looking for all this while. So please don't forget to subscribe to this YouTube channel and hit the notification bell to get notified each time we upload a video. You are also free to share this video in any form to your friends. Thank you.